Hello, ladies and gentlemen. We're going to do 4.2 today. We're going to be talking about sigma notation and area. The objectives are that we're going to use sigma notation to simplify equations and potentially do limits, and then we're going to approximate the area under a curve. So I've listed the summation formulas that we used last year when we were learning this process. So this is the precursor to integrals. So if I take the summation of C, then I get a Cn, all right? And here are just the formulas. So remember that these are something that you might need to memorize that you can use later. So let's start off by doing an example, and it says evaluate the sum, and you're going to be given that the sum is equal to, from I equals 1 to n of I plus 1 over n squared. So when we're doing these, it's important to remember that the n's are a constant because that represents the position of a term in a sequence. So it's its address. So that is a constant. And then I is actually the variable. Alrighty? So as I get ready to simplify this and start doing my summation, I'm going to pull the constant out front just like you would if you were integrating. So I'm going to do 1 over n squared times the sum from I equals 1 to n of I plus 1. Alrighty? Then I'm going to expand my summation. So here's the 1 over n squared, and I'm going to do the sum from I equals 1 to n of I plus the sum from I equals 1 to n of 1. All right, and you don't always have to write it like that, but at least it helps us to understand what we're doing. So if I continue doing my math, here's the 1 over n squared, and then if I have I, using my formula, it's going to be n times n plus 1 over 2, and then the summation of a constant is going to be plus n, right? Okay. So then what I might do is put those two guys together, and I'm going to do 2n over 2. So then I can put the tops together and pull that 2 out. So then this is 1 over 2n squared. And then on the top, I have n squared plus n plus 2n. And then if I simplify this, here's the 1 over 2n squared. And then I have n squared plus 3n. Okay, I can reduce that by factoring out an n. So this is 1 over 2n squared. I'm going to factor out an n, and I'm going to get n plus 3. That n cancels and leaves an n in the denominator. So then I'm done. So my summation is equal to n plus 3 over 2 times n. And then, of course, you have to write your answer politely. So here's my I equals 1 to n of I plus 1 over n squared is equal to n plus 3 over 2n. And so that would be that. Alrighty. I can use sigma notation to calculate the area under a curve, and it depends on the direction of the curve whether I'm going to under or overestimate the area. So we have some more formulas to consider. Well, that pen's not working so good. All right, so here are my new formulas, and we're going to be using our summations to help us find the area. So if I have f of little mi, then this is the minimum value of f of x, okay? And f of capital Mi is going to be the maximum. You'd never know that that pen is green. It looks kind of black. Maximum value of f of x, okay? The lower sum is going to be our left-hand sum. And again, remember, it depends on the nature of the curve, whether the left side is actually the lower or the higher. And then this is going to be notated as s of n, that's a little s, by the way, in case you can't tell, from the sum from I equals 1 to n f of mi times delta x. Alrighty, and if you think about, we are summing a bunch of rectangles. This is the height of the rectangle. This is the width of the rectangle. So if I were to write that, this is the height of my, hang on.
Will the following teachers please come to the small conference room? Mrs. Younghans, Mr. Durand, Mr. Hobson.
All right, there's your public service announcement for the day. So I have the height of the rectangle, and then I have the width of the rectangle. And the basic idea is that the area under the curve is just the sum of all of the individual rectangles. Alrighty? If I go to another sheet of paper for my upper sum, which is going to be our right-hand sum. Remember, once we start integrals, this all gets better. It's going to be capital S of n, and it's going to be the sum from I equals 1 to n f of mi times delta x. And again, this is the height of the rectangle, this is the width of the rectangle, and I'm summing all of the individual rectangles. Okay? All right, if I want to take a right hand, and this sometimes I think gets to be a little confusing, this is the right hand side of the rectangle, and this is the left hand side of the rectangle. And then let's say that this is under a curve, and I'm summing from A to B, right? So then my x sub I is going to be equal to A plus delta x times I, and then my x sub I could be B minus delta x times I. This one is the right-hand side of your rectangle, and this one is the left-hand side of the rectangle. Alrighty? Delta x, if you'll remember, is always b minus a divided by n. How many rectangles am I going to have in the given interval? Alrighty? N at this point represents how many sub-intervals I have. If we're doing this process, we're assuming that all of the sub-intervals or all of the rectangles are equal. But remember that I can also calculate the area under a curve, and I don't have to use equal rectangles. Alrighty, so let's just do an example. And this one says find, and actually I'm not going to do the whole example because I'm a little bit lazy, but I want to make sure we set it up so that you can see how the problems would be done. Find the upper and lower sums for the region, and integrals are so much better, we'll be there soon, by f of x is equal to x squared, the x-axis, x is equal to 0, and x is equal to 2. So I also think it's important to look at the graph to know what you're summing. So if I have y equals x squared, and then I have here x is equal to 0 and x is equal to 2, then I'm looking for the area under my curve. Alrighty? So I'm just going to set these up. So for my right endpoints, and remember the endpoints are the edges of the rectangles that we are summing, and then here's going to be the work for my left endpoints. Alrighty? Okay, my right endpoints, little mi or x sub I, kind of depends, I'm going to write or x sub I, depends on the notation, either is okay, is going to be
Savannah Johnson to the front office, please. Savannah Johnson to the front office.
Which is always the hazard of recording videos after school. All right, m of I is going to equal the left endpoint plus delta x times I. Okay? So then I need to find delta x before I do more math. My delta x is going to be 2 minus 0 divided by n, which is 2 over n. Then my x sub I, m sub I, however you want to call it, is going to be the beginning endpoint plus delta x over n times I. And that just simplifies to be 2i over n. Alrighty? And then I'm going to actually go ahead and set up the summation. So remember, it's going to be, guess you can't see it, a function evaluated at x sub I times delta x. So my area under my curve, so S of n, is going to equal the sum from I equals 1 to n of f of my 2I over n times my delta x, which is 2 over n. Alrighty? Okay? So now what I'm ready to do is evaluate this in my function, and I just found my mistake in my notes, just kind of nice. So if I evaluate the function x squared at this, it's going to be 2I over n, quantity squared, times delta x, which is 2 over n, right? Okay? Just checking to make sure I did my math right. So then this is 4I squared over n squared times 2 over n, and I need to stick my summation stuff in there, equals 1 to n, and put my summation stuff back up there so it looks better. Okay? So remember, now I need to do this math. I can pull out the 4 and the n's, so I'm going to pull out the 8 and the n cubed, and I'm going to have my summation from I equals 1 to n of I squared. Alrighty? And then at this point, I would use my formulas, and if you'll remember, I squared is a mess, so this is going to be 8, let me scoot it up just a little bit, over the n cubed. My I squared is going to be n times n plus 1 times 2n plus 1 over 6, alrighty? And then I'm going to simplify that math and then reduce my problem. So this is going to be my summation, okay? And I'm going to stop here, and I'm just going to set it up to here, and then I'm assuming that you can do that math. So then let's go back and do the left end points, okay? So if I go back and set up my left end points are going to be b minus delta xi, right? And this is my m sub I, and I like x's better, so I'm going to call it x sub I, okay? So this is going to be x sub I is going to be equal to 2 minus my delta x is 2 over n times I, and now I'm going to evaluate my function. So for my summation from I is equal to 1 to n of f of 2 minus 2I over n times delta x, which is 2 over n. Alrighty? Sorry, I know that's kind of running amok. Alright? So then if I evaluate my function was x squared, so it's going to be 2 minus 2I over n, quantity squared, times 2 over n, and this is my summation from I equals 1 to n. Before I expand, I'm going to pull him out front, so I'm going to do 2 over n, and here's my summation, I equals 1 to n. Oops, sorry, you can't see it. Okay? And then I would do this math. So if I do that, I'm going to get 4 minus, this is 4 times 2 is minus 8I over n plus 4I squared over n squared. Okay? And just like on other ones, I could put all of these together. It might make it a little bit easier, so I might do that. So I equals 1 to n, or I could evaluate each one separately, but I think at this point I'm going to put them together. So I'm going to have 4n squared over n squared minus 8in over n squared plus 4I squared over n squared. So that's everything inside. So now I can pull out a 4 and an n squared, so I'm going to get 8 over n cubed. Can't tell you how many times I did this yesterday to get the right answer. So when I pull out the 4 and the n squared, I'm going to be left with 4 over that, so n squared minus 2in plus 4I squared, and then I would continue evaluating my summation. So I could evaluate each of these separately and distribute, and you'll get about the same answer, okay? So let's talk about getting about the same answer. So yes, you would have more work to do to finish this. So you would have to do more work to finish. But it's just showing you the process of setting these up. So a concept that you need to remember is if I take the limit of my summation from I equals 1 to n as n approaches infinity of my x of x sub I times delta x, then that means that the left and the right are going to become equal. And so that's what happens if I take the limit of this process. So we're going to actually call this a formal definition, and we're going to call this the definition of the area of a planar region. Alrighty? So our formal definition for the area of a planar region, meaning that it's 2 dimensions and not 3 dimensions, says that the area is equal to the limit as n approaches infinity of the summation from I equals 1 to n f of x sub I times delta x. So remember, once we eventually finally get to integrals, this process is significantly easier. Same thing when we do our Riemann sums. Remember that delta x is b minus a over n, and my x sub I is either going to be a plus delta x times I or b minus delta x times I. Okay? This one is the right in case you don't remember, and this one is the left. All right, so let's do an example of taking the limit of our area, and this will be our last example for the video, lucky dogs. So on this one, get a different color just because we can. We want to find the area bounded by the graph of f of x is equal to 4 minus x squared, the x-axis, and our vertical lines, x is equal to 1 and x is equal to 2. So if we sketch this, 4 minus x squared is going to be something like that. That's going to be my 4. And then it's going to be bound by x is 1 and x is 2. So I'm looking to calculate this area of just that big rectangle underneath the curve. Okay? And just because I'm going to use the right side. Okay? There's no necessary rhyme or reason. That's just the side that I've chosen. So here's my function, 4 minus x squared. My delta x is going to equal b minus a over n, which is 1 over n. And since I'm doing the right-hand side, my x sub I is going to equal a plus delta x times I. Alrighty? So my x sub I is going to equal 1 plus my delta x 1 over n times I. Alright, so if I do our definition, the area is going to equal the limit as n approaches infinity of the summation from I equals 1 to n f of 1 plus I over n times my delta x, which is 1 over n. So as we look at this, remember what we're doing. This is the height of the rectangle. This is the width of the rectangle. This guy is a constant. So before I do anything else, I'm going to pull him out front. Yes, you have to write your limit notation as you move through the problem. And now you have to write your summation. So this is the summation from I is 1 to n. And then I'm going to do 4 minus 1 plus I over n, quantity squared, and that is what I'm summing. Alrighty? So if I set that up, I have the limit as n approaches infinity of 1 over n, summation I equals 1 to n, and I'm going to have 4 minus, and then I'm going to do a parentheses, the first term squared plus this and multiplied by 2, 2i over n plus I squared over n squared. Okay, I need one more. Alrighty. And then I'm going to simplify Actually, I think that's pretty simplified, but I could do that. So now I have the limit as n approaches infinity, 1 over n, summation equals 1 to n of 3 plus 2I over n plus I squared over n squared. Whew, that's a lot of stuff. All right, so I could technically rewrite each of these individual terms, but I'm just going to manage as we go. So this is, I haven't taken the limit yet, so I'm still going to continue with my limit notation. Here's the 1 over n, alrighty? 3 becomes 3n. I'm going to pull the 2 over n times I, which is n times n plus 1 over 2. And then I'm going to do plus 1 over n squared. And then this is n times n plus 1 times 2n plus 1 all over 6. And the hardest part of these problems is just simplifying all the math. All right? I am simplifying a little bit. Okay? So I can cancel that, so I have an n right there. And what I would like to do at this point is try to put as much together as I can. How did I manage that? Oh, having a brain fart. Oh, my bad. So now what I can do is I can distribute this guy. That's what I want to do next.
Will the custodian please contact the front office? A custodian contact the front office.
We have lots of public service announcements today. And then I'm going to have that n and that n cancel. So I'm going to have n plus 1 over this n. And then, except there was a minus there. Ooh, I'm just doing really bad math. That guy's a minus. So this guy is a minus. This guy is a minus. Whew, so sorry. So that guy's a minus. And then I'm going to bring in this n. So I'm going to have minus n plus 1 and 2n plus 1 over 6n squared. Alrighty? And so now what I'm going to do is simplify it just a little bit more. So this is the limit as n approaches infinity. Those two n's cancel, and it gives me a 3. And then I could split the next guy up as a minus n over n minus 1 over n. So that guy's going to simplify, and I'm going to circle it so I don't lose it. And then this one, alrighty, if I expanded everything and simplified and combined like terms, I could write it over 6n squared, and then I would have to divide every term because I'm taking a limit. So this guy, so let's do it this way just to see if we can make it look good. So I'm going to have a minus. 2n times n is 2n squared over 6n squared. And then I'm going to have 1n plus 2n's is minus 3n over 6n squared. Whew, that's a lot of math. Alrighty, those two guys cancel, and this gives me a third. I'm going to circle him. And if I do that, then I have an n there. Well, remember, as I take the limit as n approaches infinity, if I have an n in the denominator, this goes to 0, this goes to 0. Whew, that's a lot of stuff. So I get 3 minus 1 minus 1/3. And if I simplify that math, what did I get when I simplified it? I got 5/3. Whew, that was a mess. So if I go all the way back to the beginning, I would say that the area from, I'm going to write 1 to 2 is equal to 5/3. Whew, integrals are so much easier. Alrighty, that's it for today. I will see you soon after I fix your paper.